Hello, Internet. Welcome to episode 16 of the Braindrizzle podcast. This week we have a very special guest with us, Philip Moriarty, more commonly seen on the 60 Symbols channel. Hello, Philip.
How you doing?
I'm doing good. So, how would you like to be called? Professor Moriarty?
Philip's absolutely fine. Fine, yeah.
Cool. Philip, so for those few people who might not be familiar, why don't you talk about sort of what you do online?
Online, okay. So one of the people at the University of Nottingham who contributes to Brady Harron's channels, there are a number of those. The 60 Symbols. The very first one was something closely followed up by, I guess, perhaps the one that's most known is periodic videos. His most recent one has been, one of his more recent ones has been Number File, about numbers. So a series of science and maths videos. A number of us, I guess in physics there's probably 5 or 6 of us who regularly do 60 Symbols videos. So it's a lot of fun working with Brady. It's a lot of fun communicating with people via YouTube. Yeah, I certainly enjoy it a lot.
That's awesome. So, off of YouTube, what is your sort of specialty or actual work?
So I would broadly class myself as a nanoscientist, or even more broadly, a condensed matter, solid-state physicist. So I'm interested fundamentally in manipulation of atoms, imaging, spectroscopy of individual atoms and molecules, particularly using scanning probe microscopes, or exclusively using scanning probe microscopes like the scanning tunneling microscope, the atomic force microscope. So those are very sharp tips, atomically sharp.
Could you say those two types of microscopes again? Because both of you, I'm getting like really low quality
Okay.
on the call.
Okay, hang on, let me see if I can do anything in terms of the mic level here.
I think the problem's Skype, because it's actually persisting from a problem we were having before we added you.
It's more that the audio's breaking up, is it?
It's almost like the whole digital making you guys sound like robots thing.
Oh, that's a shame.
Yeah.
Okay, there's not much we can do about that.
But one of those microscope types that you just said, you could not understand what that word was at all.
Okay.
Basically, electron microscope, and then, for all I know, you said an ice cream scoop.
Okay, my accent doesn't help either, so I'll start that bit again then.
Yes, please.
Day-to-day research focuses, I would say, broadly in the area of nanometer scale science, nanoscience. We work with single atoms, single molecules. We image single atoms and single molecules, manipulate them, do spectroscopy, and our aim really is to use scanning tunneling microscopes and atomic force microscopes. So these are both, they all fall under the family, under the banner of scanning probe microscopes, where you don't have any optics, you don't have any lenses or mirrors. Instead, you use a very, very sharp tip, a tip that's a single atom, terminated by a single atom at its end. You bring that close to a surface, which is also atomically flat or atomically defined. And by moving the tip back and forth across the surface and measuring some type of interaction like a current or a force, you can image the surface at the atomic level. Our goal is to, like many in the field, is to move beyond just imaging and to actually manipulate atoms to build up structures, a single atom at a time, under computer control.
That sounds really interesting. So what initially got you into that field from the general category of physics?
That's an interesting one. I have to go back a little bit for that. So I did my degree in Dublin City University, which is one of the newer universities, younger universities in Dublin. I did a bachelor's degree in applied physics, and then I wasn't thinking about doing a PhD until the opportunity to actually work with a scanning tunneling microscope came up. And this was in 1990. And at that time, a very, very important paper had been published by a group at IBM Almaden, where they manipulated single xenon atoms on a nickel surface to spell out the IBM logo. I just thought this was fantastic, as did many of my peers, that we could not only see those atoms, we could move them around, and we're now at the point where the level of control was you could spell things out atom by atom on a surface. And that's what got me into into doing a PhD, and my PhD focused both on scanning tunneling microscopy and other techniques broadly related to surface science, I suppose, and looking at semiconductors. And then I got a postdoctoral position in Nottingham back in '94, directly after my PhD, and I've been there ever since. And the focus throughout has been on scanning tunneling microscopy.
On YouTube, you do sort of tend to cover a wide range of topics, relatively speaking. Physics pun, ignore it. So, how do you have so much knowledge? Because you do study a very specific type of physics, but then you make videos about sort of a relatively broad area of yeah.
That's a very good question. I don't have that much knowledge, I first of all say. The important thing is that as well as doing research, so I'm a university lecturer, so I teach, and we're expected to teach a broad range of topics. We're also expected to do tutorials. So in first year, if you're doing tutorials with small groups of students, say 5 to 6 students, then you're expected to cover everything from basic mechanics to not general relativity, but special relativity, quantum mechanics, right across the board. So I've taught modules in thermodynamics, Fourier transforms and Fourier analysis. What else have I done? Surface science, of course, but that's my research area. Also, one of the first things I had to do when I started in Nottingham was to set up a new undergraduate laboratory where we had a major interfacing component using something called LabVIEW, so doing computer-controlled experimentation. So I've taught on a range of different modules, and many of the videos that we do for Brady, in many cases, well, sometimes we suggest something, and if Brady likes it, then we'll go with it. Or as often as not, Brady will go, no, that's terrible, we're not doing that, that's a stupid idea. And in many cases, for example, we did a video on Portal. That was Brady. Brady said lots of people had contacted him about it. Let's do something on this. So I would argue that more of the ideas come from Brady than actually come from the physicists.
I see. And you mentioned teaching. Did you start that right when you got to Nottingham? And with advancements in online technology, would you say that teaching at your level has changed throughout the years?
What a great question. I would say it hasn't changed half enough, or a fraction of enough. You may be familiar with these massive online or open online courses, MOOCs. There's a great deal of interest in those in the UK at the moment. But let me just track back. I would say that about the worst possible way of teaching students is to pack 200 of them into a lecture theatre and talk at them for 50 minutes. That's the way we do it. And that's the way we have to do it in terms of staff resources, staff time. That's the most effective way in terms of using the staff to get the information across. In 2013, from many perspectives, that's a really, really outdated way of putting the material across. So I'm experimenting a little bit with YouTube, putting stuff up there. What I first did or tried to do was try to video lectures, and then it sort of struck me, actually, that's not really the best use of YouTube, because the great thing with YouTube and just the online community is that you can have a one-to-one conversation to somebody effectively on the other side of the screen, as it were. And it seems a little bit, I don't know, trying to take a relatively dated approach to teaching and then try to put it into package it up differently, just taking a lecture and putting it online. So I'm trying to move more towards, as are many of my colleagues, trying to move more towards a sort of online tutorial approach. If I had my way, what we do is we video the lectures or video a series of tutorials and put those online. And then instead of having lectures, take the 20 hours, or it's something like 22 hours per module that we have of lectures at the moment, and just make those problems classes, make those tutorials, make those very open-ended, and make it much more interactive.
Now, you obviously have an interest in sort of changing the way things are taught. Is that what initially connected you with Brady? Because I'm assuming there are plenty of physicists and physics professors at Nottingham, so how did you particularly get involved?
I've thought about this, and I'm actually not entirely certain the way around it was. There was an email came around. This was a long time ago, before I was aware of periodic videos or Nottingham Science or anything like that. And basically, from the head of department, an email came around, said that Brady Harron, who used to be a video journalist with the BBC, is interested in talking to academics. You want to have a very sort of raw, open approach to science. Would you be interested? I think I sent Brady an email saying, yeah, I'd be interested. Let's have a chat. Heard nothing for 4 or 5 months. And then he sort of sent me an email out of the blue saying, yeah, let's do this. And let's have a chat about some aspects of physics. And the good thing was, because it was 60 symbols, it basically kicked off, and this is still the case to some extent, with, well, what symbols are you interested in? If you were given the choice, what videos would you like to do? The very first one I was in was on the speed of light. And, you know, when you compare that, or those early videos, to the more recent stuff we've done, it's, you know, let's say things could have been, I could have explained things better, let's put it that way. Yeah, that's it. So it was quite a natural, organic process, I suppose, is the best way of putting it.
Now, do you think that Brady is pumping out a lot of videos, and some of those have you in them? Does this dynamic change the way you interact with your in-class students?
I think it does, yeah. Quite a few of the students have seen the 60 symbols videos. We're very happy, when students are making applications to university, and particularly to Nottingham, that they mention 60 symbols. I don't think it's affected the way I put material across in lectures, but I am certainly much more attuned to the possibilities of exploiting YouTube. And if I hadn't got involved with 60 symbols, I don't think that would have happened.
I see. Before we get to the future, let's go back, because this always interests me. What got you into science in the first place?
Oh, great question. Brady knows the answer to this very well. So I can pinpoint, unlike quite a few of my colleagues and peers, I can actually pinpoint when I got interested in science. My uncle was a radio amateur, radio ham, as it's called. And he used to build radio sets, and he had his own receiver and transmitter. He was very interested in wires, yes, but antennae and radio transmission, etc. And he and I, when I was about 8, built a crystal radio set. So I don't know if you know what that is, but it's the simplest possible radio you can have. You've got a diode, a capacitor, an inductor, and antennae, basically, in a little earpiece. And we built this. I remember vividly putting the earpiece in my ear and hearing a radio station, and there's no battery. The thing is powered effectively from the ether, as it were. It's powered by the radio waves, and that would made a huge impression on me. And from that point onwards, I sort of knew I wanted to be a scientist.
That is an awesome backstory.
Thank you.
So now getting to the future for you and then Brady and your involvement with those videos, is it going to be more of those videos, or do you want to really try and make videos for longer form videos or more directly course related videos?
I certainly want to make directly course related videos, but outside of 60 symbols, the last thing Brady would want to get involved in, and I think he's absolutely right, is, for example, filming 1 hour or 50-minute videos and putting those online. That's not what he does. That's not what his whole, the whole ethos of 60 symbols and all his other channels is about. He is very much of the opinion that he wants to pitch these at as broad an audience as possible. He gets frustrated, I guess, when I lapse into jargon, and I think that's one of the things that we butt heads about quite a bit, is use of language. And like many physicists, I will drop into physics mode, and then we have to back out of that, and I have to explain it in simpler language, which is great for me. It's really, really useful to do that. But that's not something, you cannot pitch an undergraduate lecture like that. And of course, the other key thing, of course, is maths, or math if you want it. We're here in the UK and also in Ireland, we say maths, but I believe that might in the US be seen as somewhat, I don't know, strange way of saying math. The key thing is, for undergraduate physics and for high school physics, you've got to have the maths in there. And that's something that's difficult, very difficult to put across in a 10-minute video.
I see. Yeah, maybe including yourself or not including yourself. Let's just stick to physics. What do you think your favorite 60 symbols video is?
So I really like the ones with James Cluett. So James Cluett was a PhD student, and he's got a very interesting backstory as well. He was world Tetris champion for like a number of years ago, but he also did first degree in electronic engineering, if I remember correctly. Left, went into industry for 10 years, got fed up with that, and then decided he wanted to come back to do a physics degree. And he was just a phenomenal student. I taught him at least 2 modules, maybe 3. He was just exceptionally good, and he's got a real talent for public engagement and for outreach, and his videos are exceptionally good. The one that he did with Roger Bowley about some of the recent results on surface tension was excellent. Roger's videos, I really, really enjoy Roger Bowley. If I were to pick my favorite of Roger's, it's probably the magnet and momentum one, because it's sort of counterintuitive. Roger was a huge inspiration to me. When I started in Nottingham as a lecturer, he came and peer reviewed a number of my lectures, and his advice was absolutely invaluable. He's a great colleague. He's retired now, so I really warm to his videos. Again, Ed Copeland's stuff, Tony Padilla, there's so many, it's too difficult to choose, sorry. And if I choose one, my colleagues ever hear this interview, they'll get upset that I didn't choose, one of their videos perhaps.
Okay, then let's make it a bit easier on yourself. What do you think is the video you feel you did best in?
Oh, let me see. I must admit, the one I'm most proud of, but not because of the physics, the one I'm really proud of is the Number File 5 video, where we did a song on the golden ratio. We collaborated with a guy called Dave Brown, who's a fantastically talented musician and producer. And we did a song where the riffs, the rhythms, the lyrics were all based around the golden ratio. I'm a before I was, while I was doing my undergraduate degree and my PhD, I was in a series of bands. I'm a musician. So that was a huge amount of fun. So that's the one I'm most proud of. From the physics perspective, I thought that the 3D glasses one came out pretty well. I thought that struck the right balance between having enough depth but leaving out the sort of minutiae, leaving out the fine detail. And I was quite happy with that one. Others, we did one on why is glass transparent, which overall is fine, and the key message is there. But the problem is, to describe that in 10 minutes, you have to leave out so much. Like, we didn't discuss refraction, we didn't discuss reflection. That's one of the things with the videos. When I look back on them, I can understand why Brady's so keen to just have a single message. But that's really the opposite of what we try and do in lectures, where what we try to do when we're discussing physics to the undergraduates is to say, oh, look at this is remarkable, we see this effect in this system, but then we see it in this system and this other system and blah blah blah, and we try and make it as wide as possible. Whereas in the 60 symbols videos, what happens is we have to focus on a single topic, and that can be a little bit tricky. But overall, I think the 3D glasses, also the theremin, I thought the theremin and the 3D glasses came out pretty well.
Theremin's rock.
Theremins do rock, yes indeed.
Yeah, I'm kind of in the alternative counterculture. Grew up in it, actually. Grew up punk, and I listened to like a lot of goth punk and industrial music. Cool. And oftentimes, like, I've actually found several goth tracks which actually use the theremin just as a serious instrument. And that was always refreshing to see, because always the theremin's usually incorporated and, hey guys, it's the theremin, volume 5. Like, the theremin is like the point. It's treated as a novelty. Whenever it gets used seriously, it's awesome.
I agree. It's a phenomenal instrument, and it's a phenomenally difficult instrument to play. And there are some exceptionally good theremin players on YouTube. And it took me all my time just getting those 5 notes from the Close Encounters theme. And even then, my pitching is well out. And these people can play it, and it sounds like a cello, or violin. It is just remarkable when you see a talented person play it. It's a beautiful instrument.
Now, Phil, I was thinking you were talking about Portal.
I'm getting fairly sick of it now, I must admit. It's an interesting, I'm not a games player. We did a video in Portal, and I'm not a games player. This was one that was very much driven by Brady, and I must admit, I downloaded it, bought it, let's be clear, and played it for a couple of hours, and it's a really remarkable game. But I'm not giving ground here. Momentum is not conserved in that game.
From the reference point of the person going through the portal, aren't they still going in one direction?
The problem is you can't do that. If you take it from the reference frame of the person, then you're not getting any additional information. The entire game is predicated on things moving through the portals and interacting with stuff in the same frame of reference. So the argument has been, there have been a number of different arguments. One argument is, well, you open up an entirely new parallel universe. Well, then fine, that's fine, you do that, but then stop talking about conservation of momentum, because if you're thinking about conservation of momentum in two different reference frames, it makes no point. There's no point in doing that. It has to be within a single reference frame. Moreover, if you take it from the point of view of the player, as it is, that player emerges back into the same frame of reference. And if you're arguing that they don't emerge back into the same frame of reference, then again, we've got an issue, because it's nonsensical to talk about conservation of momentum if you're not going to stay within the same coordinate system. Nice. So I could go on and on. I'll tell you what I really like are those emails I get. And actually, what I find remarkable is that usually I'll have debates with people, sometimes about the physics, and these are usually very, very friendly and back and forth. I've had some vicious emails about Portal. Vicious, where, you know, it's along the lines of, you're a moron, you haven't a clue what you're talking about, this is ridiculous that a professor of physics doesn't know this, etc. And then, you know, I'll exchange an email, and strangely enough, I never get a response. What I find remarkable is, like, if you go into this gaming world and you start to criticize and you start to pick holes, it seems that very many people don't like that. What I particularly love are the emails that start, well, I'm not a physicist, and I'm not a scientist, and I've never studied physics, but you're wrong about Portal, and the reasons you're wrong, and then I get a load of very strange science.
I guess the major issue is that wormholes aren't real, so it's kind of a moot point to begin with.
Well, it's interesting. It depends. Wormholes, certainly in the sense of Portal, aren't real, but wormholes in terms of distortion of space-time, that type of context, you can certainly think of wormholes, and there's quite a few academic papers on wormholes, but the type of wormhole in Portal is like no other, in that what happens is that you switch off any curvature of space-time when you emerge from the portal, and that's very, very artificial. That's entirely unphysical. But as I say in video, what's great, well, there are two great things. First of all, that the physics within the game, although it's not the physics of our universe, is self-consistent. And secondly, isn't it great that a video on YouTube picking up lots of comments about people debating about frames of reference? I think that's great. What a great way to teach physics, or to start talking about physics.
So you wouldn't recommend a physics class based around Portal?
I actually would recommend a physics class based around Portal, as long as it was absolutely clear what's physical about Portal in the sense of real world physics and what's not physical. The difficulty, the reason I guess I get a little bit het up about this, is that I've noticed, and I'm sure you've noticed, that actually Portal is being used in schools. Valve have got a whole set of tutorials or lesson plans based around physics within Portal. And that's fine. When you're away from the portal, it behaves to a certain extent. The physics seems to map onto our real world, but you could argue about conservation of energy, let alone conservation of momentum. The problem is, how can I best put this? If you confuse students about, you know, the vector quantity momentum as opposed to the scalar quantity momentum as early on as when they're 15 or 16, you know, you're confusing them, and you're stocking up a whole host of problems when they go on to either do physics or science later on in university or later on in life. I think it's a great platform in some senses to get students interested in physics and to explore the possibilities, but it's important to decouple the Portal physics from real world physics. That's an awfully lengthy response to a fairly simple question. Sorry.
That's okay. Well, one final question about Portal, I swear. So if in the game they had used the word speed instead of momentum, would that have been enough?
Perfectly fine.
So would you say that the actual physical stunts that your character the character does isn't quite right, or is that consistent?
The key thing is the speedy thing in, speedy thing out. That's fine. The magnitude of the velocity, which we call the speed, seems to be conserved. I guess you'd need to do some experiments within the Portal universe to check that, but it seems to be conserved. But what isn't conserved is the direction. And the direction is very, very important, because the example I use in a recent video where you throw a ball at the wall, it comes back at you with the same speed, but its velocity has changed. That is so important. Our entire physical laws would be very different if the quantity that was conserved was speed rather than momentum. Again, it's a question of making sure that the distinctions between the portal universe's physics and our universe's physics are clear.
I see. Well, thank you very much for talking about that. I know you probably get tons of comments and emails about it, but maybe if people keep asking you about it, you can just link them this episode and say, I've cleared everything up in this.
I'm sure I haven't, but yeah.
Yeah. Well, I think that's pretty much everything I had in mind. Jack, did you have any other questions for Philip?
Yeah, I'd like to ask him a couple of questions about his role as an educator and some of his ideas about education. Now, first, I will bring something up that has actually come up on past podcasts. Something that you said when you were talking about terminology, how you butt heads with your colleagues about over, like, the use of jargon. There's a XKCD comic where the writer of XKCD suggests that anybody who's going in to teach math or science should have to spend a year writing for simple Wikipedia. First of all, do you read XKCD, and how do you feel about the overall sentiment that is expressed with that in education as a whole?
So XKCD, I'm familiar with it via a number of postgraduate students. I've read it, I've read a number of the strips, not as much as I've read something called PhDcomics.com, but in terms of teaching students, which I think is what your question is asking, to explain things in readily understandable language as possible, I think that's very, very important. But the problem is sometimes the language we use in physics has a very specific sense compared to everyday terminology. A really simple example is work or even energy. Those are very specific senses in physics, and you have to be very careful if you're using work in a sort of colloquial sense or in a sort of sense whereby it's in a popular science article. That work in terms of force and displacement has a very specific sense. So language is important, but I think that if we throw away the idea, or we get rid of the idea that, how can I best put this? If we suggest that we should get rid of all jargon, in the sense we should get rid of all technical terms in physics and try to explain it in everyday language, then we've got a real issue. And again, then that couples back to mathematics, because a really good example is, for example, we did a video recently on negative temperatures. Now, I have racked my brains for a simple real world example that you can explain that captures the idea of negative temperatures without involving the mathematics. And I can't do it. And anything I've read on the internet hasn't been able to do it either. And that's because the concept of negative temperatures is fundamentally related to statistics, fundamentally related to distributions. And it's nigh on impossible to explain it without invoking those mathematical concepts. I think the quote is, as Einstein put it, as simple as possible, but no simpler. Sometimes you really need to have that technical jargon, if you want to call it, in there, and you also need to have the mathematical and the quantitative footing. Did that make any sense?
Yeah, that makes sense to me. Now, I used to actually, for a while, I did like customer service over the phone for a cell phone company, helping people with their cell phone issues and people who complained about their, bills and whatnot. One of the things that we were told is that we were told not to use jargon at all. Like, we would get into a lot of trouble for it because of the kind of confusion it would cause the customers, and confusion equals anger, anger equals disgruntled, which equals lost money for the parent company. But I found that I was actually able to get away with it a little bit by using the jargon in a context where I was teaching the person about what all that stuff meant.
Absolutely. So it's context and audience is key. You have to be sensitive to who your audience is. And the problem is with YouTube, you've got such a wide audience that becomes difficult. An undergraduate lecture, you know your audience. Research talk, you know your audience. It's when you're pitching to a wider audience with a wider knowledge base, or a more diverse knowledge base, let's put it that way. I think that's when it becomes very difficult.
Yes, it does. And something that you said about specialized words, like the word work means one thing to me, but to a physicist talking about physics, it'll mean another thing. Same thing goes, one that's very, very common for back in the hood, back to our roots, back where Q and I came from, the uppity internet atheists, talking about how something we ran into over and over again, the evolution is just a theory crowd, trying to explain that the word theory has a specialized use. And people would say theory means something different to scientists. Technically, no. The word theory is just the picture of events that you make from the facts that you see. I mean, I can come to a theory that somebody broke into my house and stole my TV by the fact that I walk in, there's broken glass on the floor, and there's a television missing, and the front door's wide open, like what happened in Beavis and Butthead Do America. Beavis and Butthead put together a theory based on events, and then they went looking for their TV to try to verify if that theory was true. Then a bunch of other stuff happened, known as plot. Anyway, so that is formulating a theory. And it's used in the exact same context that it is in the scientific world. It's just that with science, it's not considered a valid theory until after they've gone and found the stolen television.
Indeed, yes. It's interesting you come from that atheist background. So you're familiar with Thunderfoot?
We are very familiar. Okay, I know Thunderfoot.
Oh, okay, so I've been on a...
Name dropper. For shame. For shame.
Are you familiar with the Magic Sandwich Show?
Oh yeah, I know DPR and all that gang.
Oh, okay, good. So I know DPR. In fact, I was involved with the
sellout
charity event he did. Yeah, let's not go. I guess we all know the same crowd then.
Okay, dude. This entire group, the Internet Atheist group, is entirely incestuous. If you make a video, chances are you've talked to one of those people.
Yeah.
Bottom line. It's just a fact, man. I know a guy who, just makes videos to rant his own personal frustrations. You can actually find on another person's channel, he has a cartoon character dedicated to him, talking about Vogter and Dark Matter 2525, if you don't know who those people are. Anyway, one of them's on my Facebook. Vogter, who... he just makes videos to rant. Even he, seriously. Everybody knows everybody else. Small town, man. The Internet Atheists are a small town that all live in very scattered places.
Speaking of which, actually, this is a good way to wrap up. DPR, as far as I know, is planning another MSF charity event. Any plans to be involved again?
I should get in touch with DPR about that. So we were involved last year. I guess we got a little bit too ambitious. There were issues with the Skype feed from Nottingham and a number of things. But it was a hell of a lot of fun. It was good to meet DPR and to work with them. And I enjoyed it. It'd be good to do something again. Perhaps not quite so ambitious this time around.
Well, I'm sure either way it'll be awesome. And hey, maybe we'll see you there again too.
Hopefully.
Online, at least.
And I have one more question to ask as part of my set. And I'm very, very glad that all of this went so smoothly. My last question being, specialized terms used in certain contexts. Now, you have the term, let's say you have the term crystal, right? Yeah. And then you talk about crystals to somebody who basically went through basic science in high school 10 years ago. And they're also a part of the New Age subculture. Perhaps perhaps they consider themselves a shaman, or they follow that path, or something along those lines. They're going to get all kinds of confused, because what crystals mean to them is entirely different than what it would mean to you. There's all kinds of terms like that. Nature a lot of times means something spiritual to some people. Work will mean something that is kind of a pain in the ass to most people. Theory, consciousness, the term dimension. People think multiple dimensions at the subatomic level actually means parallel universes, like in Quantum Leap or Sliders. It's amazing, but it causes me to wonder if perhaps the problem is not so much ignorance as it is, which it's part of it, but ignorance as extension to specialization of different knowledge within different cultural groups, within different subcultures. That said, do you think that perhaps the people who are into the science education, a lot of them, rational thinkers, to the largest extent atheists, perhaps all of those aren't necessarily group so much group labels as they are cultural aspects to what is in fact a budding subculture that has yet to gain a name.
Okay, so I'm trying to pick through your reasoning there. So in subculture, in what sense? Sorry.
Oh, I'm terribly sorry. That's a specialized term. Subculture in the sense that the punk movement became a subculture, the New Age movement became a subculture. The Gothic literary movements actually sprung a actual subculture around it that now exists independent of the literature.
Sure, no, I guess that, but in this case, subculture is what group of people in terms of subculture within science education?
No, subculture within the population in which science education is important to these people.
Yeah, basically, I think what she's saying is that do you think this rationalist education science fan sort of community would become its own subculture as distinct as the other examples she mentioned?
Okay, I work food service, dropped out of high school, and then got my high school diploma from Job Corps. There is no conceivable reason why you and I should even be having this conversation, other than the fact that we are linked to the same group of people.
Yeah, but hang on. There's a very, very important distinction, which is we're going to talk about semi-technical terms. Intelligence and education are obviously very, very distinct quantities. I have friends who have dropped out of school when they were 16, if you want to call that. They just stayed in school until they were 16 and then left and went and got a job. They are substantially more intelligent than I am. I had a passion for physics, I had a passion for science, and my career pathway means that to have that, to be able to continue on in physics, I have to sort of carry on that qualifications route. I don't know about it as a subculture. I prefer to think, I don't think this is the case. In fact, I think it's going the opposite way in many cases. But I prefer to think that, that rational mindset, centuries hence would be the norm rather than a subculture. I suspect that you're right, though, is that it's a great shame that things in many ways seem to be heading backwards in terms of the stranglehold that religion can have on certainly certain areas of, well, the US at least. It's perhaps not as problematic here in the UK, but on the other hand, we have faith schools that have an awful, are treated as charities, that really, really dominate the educational landscape here. And while that's the case, then we're always going to have a problem trying to get that rational mindset across.
You have to keep in mind that the U.S. is a very, very big place. So if what you have a little of, we're going to have a lot of. And whenever you get like culture, things like that to a big enough extreme in a big enough place with enough people, there's more opportunity for things to polarize.
Yeah, there is. Yeah, I don't know. There is, in terms of cultures, overall culture and overall ideology, there is a very strong right of centre component. At least that's how it looks from this side of the pond, as it were. In terms of gun control, all the typical issues, and that's hooked into a very, very fundamentalist Christian mindset in many cases. And I don't.
Yeah, these things, though, while they coincide, they don't necessarily. Basically, they come in the same basket a lot, but they don't necessarily have all that much to do with each other. Like, people don't become pro-gun because they're fundamentalist. They become pro-gun because their fundamentalist friends are pro-gun. I am pro-gun, and I am as far from being a fundamentalist Christian as you can get. So.
It's interesting. Maybe for another day we can come back to the pro and anti-gun. That would be an interesting one to discuss.
Oh yeah, because our podcasts are not controversial enough. Let's bring in gun control.
Hey, come on, man! It's called progress, marching toward extremes.
Well, I think that we've wasted enough of your time, Philip. Thank you so much for being on the podcast.
That's great. Thanks. I really enjoyed it.
Awesome.
Okay. See you then.
Bye bye.
Peace.